I think science is absolutely at its best when everybody understands and has access and can understand and ask questions and not feel belittled or feel like they're stupid because they're just not exposed to it.
Welcome to the Industry of UX, a podcast crafted to review, share, and discuss the ins and outs of the user experience industry. Let's dive into the episode. Hello, you wonderful UXers. Welcome back to another episode of the Industry of UX. I'm your host, Filippo Lovotti. I'm glad to be here with you today. I always wondered how UX is applied to different industries. Last Friday, we talked about UX in space, and before that, we discussed the design of physical products. Well, hold on to your burners and beakers, because today we talk about, drumroll, UX in Science with Nate Patrick, lead user experience designer at CAS. See, so many of us in UX come from graphic design, development, product or project management, or some sort of position in the digital field. The interesting thing is that Nate comes from biochemistry, which is a completely new entry point into user experience. Today, Nate and I talk about his intro into UX, how he approaches design to solve complex issues, how UX is perceived in the scientific world, and how he leverages best practices to make science accessible to everybody. Nate is also open to mentoring, so if you're interested in getting in touch with him, listen until the end of the episode or check out theindustryofux.com for info on how to do just that. Let me know what you think about the episode by leaving a comment on our subreddit, The Industry of UX, or by tweeting at IndustryUX. No offense to Android users, but if you like the episode, go on Apple Podcasts, give us a good rating and a review. It helps us climb the charts, bring the podcast to a bigger audience, and ultimately produce a better show. Okay, on to the conversation with Nate.
I think it's really interesting. UX wasn't really on my radar until I realized I had been doing it for some time. And I think that's all, I've heard that from a number of perspectives. I come from a small town in Ohio, and my grandfather had an interior design shop where I played around in as a kid. My mother worked there as well. And my grandfather was, how do I say it? He's kind of like a Renaissance. He was a Renaissance man, a little bit like he was a big time. He loved music. He'd tell you everything you wanted to know about music, even to like vocalizing the most minutia aspect of the music he was into. And so we also like to draw and talk about design and things like that. And so being immersed around that kind of got me interested in the field early on as a kid. And then as you're going through, like the technology boom happened. I grew up in the 90s, so I remember the first time I saw the internet. I was at my dad's office and they had just gotten the internet, and it was 1999. And I was like super jazzed about Star Wars coming out, like episode 1. And of course I was like a kid at the time. I think it was like 10. And so I remember going on the internet and like, oh, let's see everything we can find out about Star Wars episode 1. And that's kind of where that was my first interaction with the internet and stuff like that. And then as time progressed, I got my own computer, and I remember dabbling with PowerPoint of all things. Like that's the most intricate thing I had to play around with for a design space. And so I do everything from like make a website because I thought I was interesting enough at 13 or 14 to have a website. I wasn't, but it was then, taking PowerPoint and like, okay, let's take pictures of Star Wars ships and let's jam like a space background in there and use animation to kind of, make these scenes with shapes and stuff like that from a Star Wars movie. And I remember doing that and having so much fun with that as a kid. And I didn't think at the time that would ever play a significant role in my life. It's one of those things that you just kind of reconstitute as a throwaway moment from your youth. But eventually I found that the lessons I took away from that, if there are lessons to take away from that, kind of factored into like customer and user delight with applications and stuff like that. Really tweaking the finer points of like, oh, I want the spaceship to fly like that, or I want the laser bolt to go like that, is not dissimilar from like how we try and dynamically create web pages these days, or even applications and stuff like that. And I'm probably rambling at this point, but UX kind of crept in a little bit more in college. I originally wanted to go. I don't even remember wanting to go to school. I don't think I really did want to go to school, but it's one of those things that my generation, it's like, yeah, you're going to go to college, you're going to do the thing, and you're going to grow up, and you're going to have a job, and you're going to do all those things. I didn't really care about that at the time. For some odd reason, I was mostly more interested in making friends and doing stuff like that. But I went to college up in Columbus, Ohio, and I decided to go in for pre-med. And there was a lot of people in my starting classes and stuff like that. And I went to a smaller liberal arts college on the east side of Columbus. And what I found was immersion and exposure to really interesting concepts, like chemistry and biology and the computational aspects of those things. And as I started to delve deeper into those, I got more into the writing aspect of science. And so I took a really hard right away from anything creative, right? Like science is extremely analytical. It is not the most creative field in the world, although I know that there are people out there, if they hear this, to be like, oh no, you have to absolutely have creativity in science. And that is true. Like, but it's a different type of creativity, right? If I'm trying to design a molecule to have a specific purpose, I have to think creatively about A, how to make that in the laboratory, and B, how to get it into the medium by which I need to deliver it to whatever we're designing it for. Specifically, a mentor I worked with back in the day, he and I were designing a molecule. It's not exactly cutting edge at the time, and it was undergraduate research, which isn't like PhD level hard stuff, but we were designing fluorescent tags, basically a way to get molecules to light up when they're in under fluorescent light, and attaching those tags to bacteria, specifically a bacterium called Pseudomonas aeruginosa. And that was meant to the whole focus was basically like, let's get the bacteria to light up when they're quorum sensing, which is just an amalgam, like these bacteria are grouping in the lungs of cystic fibrosis patients. And so to do that, you could basically come up with a way that dissociated this phlegm in people that had cystic fibrosis. And I learned a lot from that. So many interesting aspects about that, because I had to make posters about how to present this stuff. So there was a little bit of a design aspect there, which I love. But B, you had to write about it, and you had to be able to stand up and explain extremely complicated concepts to people that have no idea what the hell you're talking about. And that's kind of where I got thinking, like, science doesn't really have an intersection with design. When you think about other fields like architecture, where it's a lot of creativity and not necessarily, there are technical aspects to architecture as well. People in the architecture field have a vast array of writing and reflection about their work. Science writing is extremely technical. And while it can be reflective in some regards, I often find that the accessibility of that information, not just like how people imbibe it, but like the degree of which they understand it. It's like the ELI 5 thing from Reddit. Explain like I'm 5 years old. I try and do that with every concept that I talk about in science, like, because I would like the uninitiated in science to be able to understand these concepts and then develop the ability to talk about them and not be intimidated by it. I think science is absolutely at its best when everybody understands and has access and can understand and ask questions and not feel belittled or feel like they're stupid because they're just not exposed to it. And that's a very interesting part, which I think has some kind of crossover with UX, because everybody should be able to use the same tools to the same capabilities. So yeah, I think that's kind of my that's, I guess, my elevator pitch regarding like how I feel about UX. That I think it's drawn upon the accessibility aspect from other fields, wherein I want everybody to be able to have access to the same tools and use them in the same way and get out of them what they need to get out of them, and not feel less than or like they can't because they don't understand something.
That's pretty cool. In UX, we meet a lot of graphic designers or developers that more or less gradually move into UX. But you come from a scientific background, which is very different and I find very interesting and unique. And speaking of interesting and unique, how do you leverage UX in your position at CAS?
One of the most interesting projects I've gotten to work on is a feature called retrosynthesis. Retrosynthesis is a concept within organic chemistry, which is a branch of chemistry that focuses solely on carbon. Every molecule that you work with in organic chemistry has a carbon backbone. And so carbon interactions are kind of the crux of how not only small molecules, but all the way up to like macromolecules and proteins and other, even into pharmaceuticals are created by way of a bunch of other different types of disciplines in chemistry. But retrosynthesis is basically approaching a problem of creating a substance by working backwards. And so, in order to do that, scientists have traditionally worked it on pen and paper. That's how I learned to do synthetic reactions when I was in the lab as an organic chemist. And I taught organic chemistry for a couple minutes once upon a time. And one of the best aspects of that was teaching people how to work backwards in their work. I always said, like, if you had a mathematical equation and I tell you the answer, could you get to that answer by working backwards using the equation? And it's kind of like that, right? You have to, it's, it's like building a Lego set in reverse, which doesn't work for Legos per se, but it does work for these environments where we can understand these reaction environments and things like that. So the computational aspect of designing a program to help people with retrosynthesis, it was a really unique opportunity and something that I had never been exposed to. And it was awesome because I got to design and help in a project that I would have used when I was more of a full-on chemist on a wet bench. I wish I had this tool when I was a kid and able to use it. So the design challenge was, how do we create a product? How do we create an application that allows people to build reactions using millions of molecules to solve problems and create what they want to create in a laboratory? How do we present that information to them? And so it's marrying the visual aspect of reactions in a really slick visual. It's also combining the ability to tweak the design of that plan, and then allow them to continue to tinker and change out variables and look at reaction information and eventually get it to where they have parameters or a plan that they can take outside of the application and go into the laboratory, and they can work and make that substance as long as they have the materials on hand that they need to do that. Does that make sense? This is, I always try and I always feel like people start to glaze when I talk about stuff like that.
It sounds like you're almost creating a simulation type product, a place where they can conceptualize things before making them in the laboratory.
Yes. So it is very simulation based because it'll tell you, like, oh, well, we can go this synthetic route with it. We can go this synthetic route with it. But if you go route A, you're going to need this material and that material in this amount of time, and you got to do this thing. I guess the best way to say would be, like, it's like plotting a course from Los Angeles to New York. And there's many ways you could go, right? Like, it's almost like all roads lead to Rome. You can go up through Denver. You can go across Route 66. You can go through Texas. You might need to refuel somewhere in Kentucky, but you'll get there eventually. Just follow this plan, and you will get the necessary amount. But it's complicated even further by the fact that the simulation would need to tell you, yeah, if you do it this way, you're only going to get about 66 to 77% yield. And percent yield is telling you basically how much of that pure substance you're trying to get will be efficiently elucidated out when you go to purify your reaction. So for organic chemists, percent yield is kind of like the end all be all variable when they're looking at what reaction they want to use. And then I guess the next one would kind of be like, well, what materials do I have on hand? Do I have to go shopping? Where do I do that? How do I get these materials? And so it's really a multifaceted problem that we're trying to solve. And it's never going to be 100% done, I'm sure, but we're always iterating and tweaking things to make the workflow better for people that are trying to solve these problems for others. And I think that's the most important thing that I try and keep in mind, is like, I'm trying to solve a problem for people who are trying to solve problems for other people.
That's so interesting, and for a lot of different reasons. And the last thing that you mentioned really resonates with what I do at Zappos. Essentially, my team and I create the products and services that the customer service team gets to use to solve customers' problems. And so technically, I'm not designing for the customers directly, but I'm designing for the users that then will use these solutions to help the customers. So what that means is that now you have layers and that can compound to become even bigger problems. Anyway, how do you test products? And how do you approach accessibility?
That's a great question because the nature of what we're designing is, as you said, multi-layered and multifaceted. It's almost impossible to account for content that would sit within the system. So one of the things that continues to potentially happen when we're in these testing sessions is like, a scientist would be working in the prototype we've developed and they see something that's not quite science or not exactly science accurate. And they go down a rabbit hole of explaining, like, well, that's not right because you'd have this reactant and it would actually become that product. And so it is a very real challenge because mock data doesn't work in these prototypes. So you almost have to kind of work within the space to know, like, what is a very rudimentary reaction that I could run in front of people to help them understand and grasp the concept of understanding the experience and if it's working for them and if they feel like they could derive their information into the system and get the answers they expect. So it's almost two prong where it's like, does the design work? And then the other aspect is like, well, are you going to be able to get the information you're wanting to find? These search services, search within the science realm is so much different than how we're used to with something like Google or DuckDuckGo, or I guess if people use Bing. I don't think people use Bing anymore, or ever. But it's not like with Google. If I type in Mustang, I could get a horse. I could probably get a car. I could get something somewhere in between those. But it's going to generally know based on my search history and the analytics and metrics that it's picked up on watching what I do that I'm probably meaning the car because it sees that I'm looking up a bunch of Volkswagen designs or Audi stuff. And it's like, oh, he's got a history of looking at cars. He probably wants to look at the new electric vehicle that they put out. But it's not the case with science because what one person could input could have a totally different context than how the machine is parsing it. So that is an interesting challenge to design for as well. Regarding the accessibility of those things, I think that's one of the most challenging aspects of this. Not only are the names for molecules really complex, a bunch of numbers and dashes and commas. To lay people is just, it looks like code, right? But there's a system in place that helps people parse a structure from a line of text. And there's multiple systems to do that too. There's Inchi code, there's what's called a smiles. Those are computer scripts. It's like a line of text that basically interprets a structure into a structure builder. And so you could say, like, it's almost like binary, but for words or for molecular structures. So like how binary would translate into data, a smiles code or a molecular code of that sort would translate into a molecular structure. So there's that aspect to it. There's also designing for contrast, designing for information hierarchy. There is a particular challenge that we've looked into the past year and we've been working on is making sure that screen readers and other accessibility tools are prioritized because it is a particularly interesting challenge to be able to explain to a person with a visual impairment that this is the structure you're seeing on a page. And that structure might have a very long name. So it's really finding that balance to where it's like, well, is there a common name or a better way to convey that information to the user? And that's extremely important because to go back to what I said earlier, science works best when everybody is able to use it and understand it. Not everybody that is a chemist has vision. Not everybody that is a chemist has hearing. And making sure that we're creating an environment where everybody has access to the same information is paramount to an equitable future for science.
I know you are passionate about accessibility. How have you approached or scaled it to the retrosynthesis product you mentioned before?
Well, it's particularly interesting because WCAG compliance, which is for those the uninitiated, is Web Content Accessibility Guidelines, which is practically the ADA, or the Americans with Disabilities Act, compliance for the internet. And I can only speak from a perspective as somebody that's in the United States. But basically, when it came down to it, implementing WCAG compliance and compatibility into the flagship product that I work on was absolutely a no-brainer, because it allowed everybody, regardless of capability, to have access to this platform. And some of the discovery sessions that I was leading when we were investigating, like, how do we do this? I talked to a really amazing scientist up in the New England area, and she was telling me that she's like, so many areas of science aren't accessible at all. And it was really eye-opening for me to be able to understand the plight of people with different capabilities, and making sure that they can live and work in the space and use the tools that everybody uses with the same level of equity that everybody deserves. So it was a huge task to understand all of these things and then retroactively implement them to where everything would work, and making sure all that's transparent and understood, working with developers who also had never been in the space or done anything like that. What's an ARIA tag? How do I apply this stuff here? It was amazing. And I can't say enough good things about the team that I work with, to be able to be willing to just jump in and let's conquer the unknown, and let's find out what we have to do to make this the best possible version we can for everybody.
I think you bring up a great point. There is a theme that I keep hearing, and I'm really interested in exploring that. And it's that science has to be technical, and technical has to be dull, and technical has to be complex. You just mentioned that you advocate for more accessible information. Are the complexity and the rigor a must of the industry, or are they just a norm?
I think it's a norm. It's a historical norm of the industry that it's complexified information. Does it have to be that way? I don't believe so. There's going to be a myriad of opinions on that. But I think one of the best way it's manifested itself for everybody to see as of late, we're all living in this post COVID-19 world now. Vaccines are dominating the headlines. I think people that are able to make it consumable and accessible to people and take that complexity out of it are really the kind of champions of the era. One example, case in point, made news the other day. I saw there's a biochemist out of Cornell. His name is Rob Swinda, and he made a video explaining how the COVID-19 virus, or the COVID-19 vaccine works. And he did it in a way that was meant to help his mom understand it. And that resonated with me, because that's always been my mantra too. Like, I want to make this information consumable to people like my mom, who has no idea about molecules and stuff like that. I mean, she probably has an idea because I've talked about it for years and years, but that really resonates with me, because it doesn't have to be the stereotype of extremely complexified data that people have to be afraid of. Science and chemistry and biology and physics are nothing to be afraid of. It is just a set of information and rules that govern. I mean, I'm going to sound like Neil deGrasse Tyson or something here, but it's like the set of rules that govern the existence of everything, right? Like, that's what drew me to this industry, was because it makes up everything we touch, everything we smell, everything we see, how we smell, how we touch. That is the beauty of science. And that's why it is so interesting. But people that are able to make the information more accessible to others, so where it's not a scary thing, or it is easily understood, even though you may not understand all the vocabulary, the lexicon around those things. We can have a shared language about, like, oh, this is what a vaccine is. This is why it's good. This is how vaccines work. And I think that is a very noble effort to, as we've seen the last 5 years, to combat the scourge of falsified information, or the biased slant of information that's kind of assaulted our reality as of late.
Okay, this is something I've wanted to ask you since we scheduled our chat. How is UX perceived in the scientific world?
That's a really interesting question too. I think that UX is starting to reach a point where, as science and the industries are moving towards more technical models, they're working collaboratively with information architecture and technology teams. UX hasn't always been in the forefront of how these things work. I can show you a lot of visuals from software in like the Windows 95 to Windows XP era that is not necessarily designed forward. One of the machines I used when I was in college, I remember specifically, it's an NMR, and that NMR stands for nuclear magnetic resonance. And basically, it's an MRI machine to identify molecules after you've kind of made them in a laboratory. It creates a graph that scientists can interpret and confirm that they've made the substance that they were targeting to make. And if you look at running this computer, which ran on, I'd say maybe whatever came after dot matrix printers, it was not pretty. So that's also what got me thinking, like, does every software have to look horrible in the sciences? I think it's been a new area of intrigue for multiple institutions around science to start to integrate user experience principles regarding the way people ingest this information, the way people have access to this information. And we're starting to lean that way. There have been organizations that have written manifestos and doctrines about UX practices in the sciences. I have spoken with some of those people, and I think that there's still room for science to improve and grow regarding UX practices and principles. I still, one of the most, it's funny actually, hilarious things we hear out of research sometimes is like, oh, there's not enough information on the page. And I'm always sitting there watching these sessions and I'm scratching my head. I'm like, well, how much more information needs to be on a page to where it meets your satisfaction? So one of the most interesting things is that scientists and the people that use these applications, they're not intimidated by cognitive overload. They're already potentially cognitively overloaded because of the complexity of the information they're working with if it's cutting edge stuff. So really, like, they hate white space. They don't like the idea of a blank page that doesn't have room for a graph or a table or any other information that could be necessary for their process. So it's taking the rule book of what we might have found out on consumer facing applications and stuff like that and completely starting from square one. Our general user does not care much about white space, but it's interesting. It's not necessarily a demographics thing, but in watching a lot of user research and reading a lot of research and talking to a lot of people, it's it's almost like two camps. It's the people that had the pre-iPhone software, like when Apple kind of simplified tools and everything was kind of taken from skeuomorphism to flat design and stuff like that. And they want those really information dense interfaces that, it's panel after panel after panel after checkbox after radio button after drop down, and it's so much to where, like, I will look at old software that I used 10, 15 years ago and I'm like, how the hell did I ever make sense of what I was doing?
I know, right? Same here. That's the beauty of the evolution of design. Now, speaking of evolving and transitioning, what advice would you give to a UX designer thinking of moving into your industry, the scientific industry?
It takes a lot of listening. It takes a lot of understanding the problems, and it takes a lot of walking around in other people's shoes. Not every case that I try and solve, I have experience in. Chemistry is extremely, and science in general, not just chemistry, but like biology and physics and stuff like that, is extremely complexified. So while it might be a daunting task to try and understand the problems, it is sitting in meetings and asking questions and not being afraid to ask those questions or not worrying about sounding stupid. I worry that a lot of people these days, it's not just a UX problem either or a design problem. It's people are afraid to ask questions because they don't want to be perceived as dumb or whatever. Like that, that's not how we learn. And there is nothing wrong with asking a question or saying you don't know. Asking those questions are how we learn things. and how we learn. And when we learn things, we're able to problem solve better for the spaces we don't yet comprehend or know. So I would say entering a design space in the sciences just requires a lot of hunger for the space and making sure that you're wanting to actually problem solve and understand the content that we're trying to display to customers and users and stuff like that. And also understand that while there are dedicated principles to UX design and interface design and product design, every industry may approach those things a little differently, and that the content and information may not scale as well as it does in other things. That's not to say that one is greater than the other by any means, because we're still ultimately, as a practice, solving problems for people in the digital space and creating tools. It's not graphic design. It is not the beatification of these things. That is an added benefit. It's really crafting tools for people to understand, and at the end of the day, solve problems, not only for themselves. Maybe it is for themselves. My example is, like, if I need to order medical supplies for myself, I don't want that to be a hard thing. I'm already struggling with the fact that I have to order medical supplies for myself or a loved one. Help me accomplish this task the best I possibly can in the shortest amount of time I can. And then similarly, if it's highly complexified stuff where you're taking a nebulous concept, give me everything I need to answer some questions so I can move on to the next thing and continue to find the solution to the problem I am seeking to find.
Nate, thank you so much for coming on the show. I've enjoyed our chat so much. Do you mentor UXers, and how can folks reach out to you?
I am absolutely open to mentoring. I have had amazing mentors throughout my career, and I don't know if I believe in karma per se, but I love to talk about this stuff with people and just bounce ideas and hear their struggles and their concerns. I have mentored a couple people in my career, and it's extremely rewarding. I always just say to reach out on the networks you find me. I'm not a big social media person. I am not the best Twitter person. I mainly stay on there for news and to occasionally, scream a blurb about UX into the void. I'm able to be found on LinkedIn, where people can reach out, and my Twitter is out there as well. It's at NSJPatrick. So yeah, I love talking about this stuff and hearing how other people are working. If there are other scientists out there that just so happen to stumble across this that are somewhat in the design space for scientific tools or another niche thing, all the better. I'd love to hear about that.
I hope you enjoyed the episode. If you're interested in any of the resources we mentioned, all the links are on the episode page of our website, theindustryofux.com. Thanks to Nate for coming on the show. Thanks to Youssef Hemimi for the audio engineering work. And a big thank you to Demi He for the post-production work. If you have any feedback about the episode or the show, you can tweet @IndustryUX or leave a comment on our subreddit, The Industry of UX. If you really want to help or say thank you from the bottom of your heart, please leave a 5-star rating and review on Apple Podcasts. It helps us climb the charts and bring our show to a bigger audience. Last but not least, thank you for listening, and I'm looking forward to talking to you next week.